Welcome to the Cleveland State University Civil Engineering UTC team overview. I am Philip, a PhD student.
I am Ibrahim, a bachelor's student.
I'm Abdul, a PhD student, and we are excited today to present our project. And we would like to take this opportunity to thank the Reed Center and alongside our Cleveland State faculty advisor, Dr. Emmanuel Kidando, and in cooperation with Dr. Kitali from University of Washington, Tacoma. Today I'll be introducing my project, Shared Micromobility as an active transportation mode in mid-sized cities and small towns. The use of shared micromobility devices such as e-scooters and e-bikes as a mode of transportation has rapidly increased all over the world to be considered as an alternative to public transportation, completing over 500 million trips in 2022 all over the world. This mode of transportation has stamped its mark in the transportation market in the United States. However, this number implies that the number of crashes that involves this type of users has also increased, and it has increased rapidly. Considering this as key aspects, this project aligns itself with a major goal of studying and understanding the usage patterns of shared micromobility, especially in mid-sized cities and small towns that we have in the United States. So we aim at understanding the following: who is using this type of transportation, for what kind of trips, what affects their ridership, and is there equity in accessing these devices in either mid-sized cities and small towns. And to cap it all, we want to understand the factors affecting the safety of the micromobility users. So to encompass this specific objective, we are currently focusing on two studies, one of it being understanding the body injury patterns and associated severity for the micromobility users, and the other study that we are currently working on is to understand the factors that influence the micromobility crashes and the injury sustained that they are having. Generally, the findings from these studies are aimed at improving safety, equity, and accessibility of the micromobility devices to any micromobility users in both mid-sized cities and small towns that we are having. Currently, we are using the data from Washington State to perform our analysis from both studies that I've previously mentioned. Thank you.
I'm introducing my project, examining the impact of vehicle automation levels on road safety in rural areas. In the United States, over 90% of vehicle crashes can be attributed to driver error, with rural areas consistently experiencing a higher rate of vehicle fatalities per distance traveled versus urban areas. To mitigate crashes, newer vehicles are increasingly equipped with technological features such as warnings for forward collision, blind spot, and lane departure, automatic emergency braking, lane keeping assistance, and adaptive cruise control, with these and similar technologies being collectively known as Advanced Driver Assistance Systems, or ADAS. However, in rural areas, vehicles are likely to be less technologically advanced, thus having fewer or less advanced ADAS. The systems present will often face suboptimal roadway surface and pavement marking conditions, causing challenges for, or in some cases total failure of ADAS, especially in adverse weather conditions. Additionally, the demographics of rural areas, which feature large populations of older and elderly adults, influence driving behavior and the perception and use of ADAS. Given the unique conditions of the rural environment, it provides an interesting context for understanding the full interaction between ADAS equipment and engagement, the environmental and exposure conditions, and demographics, particularly age. Thank you.
I'm introducing my project, Accessibility of the Emergency Medical Services to the Elderly Drivers in Rural Roadway Crashes. One of the thrust areas of the Reed Center is accessibility. Although only 19% of the population lives in rural areas, more than 70% of the 4 million miles of roadways in the United States are in the rural areas. In 2020, rural areas faced a significant challenge in road safety with 1.84 fatalities per 100 million miles traveled compared to 1.08 in urban areas. On average, Road travel in rural areas is dangerous and even riskier for fatal accidents. Immediate access to post-crash care is crucial. Emergency first responders need to quickly locate, stabilize injuries, and transport older adults to medical facilities. Post-crash care is a pivotal element of the safe system approach adopted by the US DOT to eliminate fatal and severe crashes. The research aims at assessing the accessibility of rural disadvantaged populations, particularly the aging residents. The ultimate output will be visual perception and cognition assistance system, framework, and a baseline model addressing the vulnerability of elderly drivers in rural areas. Our project will inform transportation planners and policymakers about desired technologies to enhance the safety of elderly drivers and increase mobility to seniors in rural areas.
Thank you for your time.
Your questions and comments will provide valuable insights.
More details will be provided in the series of presentations and lectures during the conference sessions.
Go Bikes!